My dear students, welcome back to our channel. In this video, I will be explaining the MBA second semester subject Operation Research as prescribed by Osmania University, Palamuru University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 4 first important short question is: what is CPM? Critical Path Method. CPM, Critical Path Method, is a project management technique used to plan, schedule, and control the activities of a project. It helps to identify the longest path of activities, called the critical path, that determines the minimum time needed to complete the project. Key point: if any activity on the critical path is delayed, the whole project gets delayed. Example: imagine building a house with activities like: A is equal to build foundation, 5 days. B is equal to construct walls, 4 days. C is equal to install roof, 3 days. D is equal to paint, 2 days. If ABCD is the longest path and takes 14 days, that's your critical path. If painting, D, gets delayed by 2 days, the entire project takes 16 days. Why it's useful? Helps managers focus on important tasks. Avoids unnecessary delays. Saves time and cost in big projects. CPM is equal to clear path to completion. Next important short question is: 2. What is earliest and latest time? What is earliest and latest time? In project management, CPM PERT, earliest time and latest time help to find how soon or how late an activity can be done without delaying the project. 1. Earliest start time, ES. The soonest time an activity can begin, based on when previous activities are completed. 2. Latest finish time, LF. The latest time an activity can finish without delaying the entire project. Example: suppose activity B depends on activity A. A takes 4 days, so B's earliest start, ES, is equal to 4. If the total project time is 10 days and B takes 3 days, then latest start, LS, is equal to 10 to 3 is equal to 7. This means B must start by day 7 and can start as early as day 4. Why it's important? Helps identify flexibility, float. Focus on critical activities. Prevents project delays. Think of it like a train schedule: what's the earliest you can leave and latest you can reach without missing your goal. Next important short question is: 3. What is crashing? Crashing is a project management technique used to complete a project faster by reducing the time of critical activities by spending extra money or resources. Why crashing is done? When a project is getting delayed or a deadline is changed, crashing helps speed up the project by shortening the duration of critical path activities. Example: suppose a task is planned for 5 days. By hiring more workers or working overtime, it can be finished in 3 days, but this may increase the cost. If the total project deadline is reduced, crashing helps achieve it, but only critical path activities should be crashed, or else it won't affect the total time. Key points to remember: crashing is equal to reduce time plus increase cost. Only crash critical activities. Aim is to balance cost versus time. Think of crashing like taking a taxi instead of a bus to reach early, but it costs more. Next important short question is: 4. What is PERT? PERT stands for Program Evaluation and Review Technique. It is a project management tool used to plan and schedule activities in projects, especially when the time to complete tasks is uncertain. Why PERT is useful? PERT helps to estimate the time needed for each activity by using three time estimates. 1. Optimistic time, O, if everything goes well. 2. Most likely time, M, normal time. 3. Pessimistic time, P, if things go wrong. The expected time, T, is calculated using the formula. T is equal to O plus 4M plus P, 6. Example. If a task may take 2, O, 5, M or 8, P days. T is equal to 2 plus 4 times 5 plus 8, 6 is equal to 30 divided by 6 equals 5 days. Key points to remember. PERT is used for uncertain projects. Helps in planning and decision making. Useful for R&D, software, construction projects. Think of PERT like checking best, average, and worst case travel times before a trip. Next important short question is 5. What is Fulkerson's rule? Fulkerson's rule is a simple method used in network diagrams, like in CPM or PERT, to number the activities or events, also called nodes, in a proper sequence. Why we use it? To make sure that every activity has a clear starting and ending point. There are no loops or backward jumps. Steps of Fulkerson's rule. 1. Start with the first event, node, that has no incoming arrow. Number it as 1. 2. Move to the next nodes which become available, i.e., all activities going into them are already numbered. 3. Continue numbering nodes such that the number increases from left to right in the network. 4. No two nodes can have the same number. Example. If activity A goes from node 1 to node 2 and B from 2 to 3, the numbering is 1 to 3, no backward flow. Fulkerson's rule ensures logical flow and helps in project planning easily. Next. Unit 4. Long questions. First important long question is determination of ES and EF in the forward pass and give example. What is forward pass? In network analysis, CPM PERT, the forward pass is the process used to calculate the earliest start, ES, and earliest finish, EF, time of all project activities. It helps us answer. What is the earliest time an activity can start and finish without delay? Definitions. Earliest start, ES the earliest time an activity can begin after the previous one ends. Earliest finish, EF the earliest time an activity can finish. Formula EF is equal to ES plus activity duration. Steps for forward pass. 1. Start from the first activity, usually at time 0. 2. For each activity. ES is equal to EF of previous activity. EF is equal to ES plus duration. 3. If multiple activities lead into one, take the highest EF of all preceding activities as the ES of that activity. Example. Let's say we have 3 activities. Activity duration predecessor. A 3 days. B 5 days A. C 2 days A. Forward pass. Activity A. ES is equal to 0. EF is equal to 0 plus 3 equals 3. Activity B. ES is equal to EF of A is equal to 3. EF is equal to 3 plus 5 equals 8. Activity C. ES is equal to EF of A is equal to 3. EF is equal to 3 plus 2 equals 5. So, the forward pass helps plan the earliest possible project schedule. Why it's important? Helps identify early delays. Useful to determine the project completion time. Helps in resource planning and scheduling. Easy tip to remember. Forward think early. Start from 0, add durations as you move forward through the network. This method is essential in CPM and PERT for efficient project planning and management. Next important long question is 2. Determination of LS and LF in the backward pass and give example. What is backward pass? The backward pass is the method used in network analysis to find the latest start, LS the latest time an activity can start without delaying the project. Latest finish, LF the latest time an activity can finish without affecting the deadline. Formulas. LF is equal to LS of next activity. LS is equal to LF activity duration. We calculate LS and LF by moving backward from the last activity to the first. Steps for backward pass. 1. Start from the last activity. Set LF equal to the project completion time from forward pass. 2. For each activity. LF is equal to smallest LS of all next activities. LS is equal to LF duration. 3. Continue backward through the network. Example. Activity duration predecessor. A 3 days. B 5 days A. C 2 days A. D 2 days B, C. Let's assume project is completed in 10 days from forward pass, so LF of D is equal to 10. Backward pass. Activity D. LF is equal to 10. LS is equal to 10 to 2 is equal to 8. Activity B. LF is equal to LS of D is equal to 8. LS is equal to 8 to 5 is equal to 3. Activity C. LF is equal to LS of D is equal to 8. LS is equal to 8 to 2 is equal to 6. Activity A. LF is equal to minimum of LS of B and C is equal to min, 3, 6 is equal to 3. LS is equal to 3 to 3 is equal to 0. Why it's important? Helps identify slack time and critical activities. Helps in resource allocation. Ensures project is completed on time. Easy tip to remember. Backward think deadlines. Start from project end, subtract durations as you go back through the network. This technique is essential for finding the critical path and managing project timing effectively. Next important long question is 3. Discuss the steps involved in the procedure of project crashing to establish a time-cost trade-off for completing a project. Problem. Project crashing steps to find time-cost trade-off. What is project crashing? Crashing means reducing the project duration by adding more resources, like manpower, machines, overtime, to finish activities faster, but it increases cost. Goal: minimum time at minimum additional cost. Steps to crash a project with example steps. Let's understand with an easy step-by-step crashing procedure. Step 1. Create a network diagram. List all activities, their durations and draw the network. Example, activities ABD and ACD. Step 2. Do forward and backward pass. Find earliest start, ES, earliest finish, EF, latest start, LS, latest finish, LF. Identify the critical path, activities with zero slack. Step 3. Find crash cost per day. Use formula. Crash cost per day is equal to crash cost normal cost. Normal time crash time. For example, activity B. Normal is equal to 6 days, 600 rupees. Crash is equal to 4 days, 800 rupees. Crash cost day is equal to 800 to 600, 6 to 4 is equal to 100 rupees per day. Step 4. Choose activity to crash. Pick the activity on the critical path. Choose the one with the lowest crash cost per day. Step 5. Crash step by step. Crash activity by 1 day at a time. Recalculate project duration and critical path. Keep a table, day crashed, extra cost added, new duration. Step 6. Repeat until you reach desired time. Stop when desired project time is reached, or no more crashing is possible, or cost becomes too high. Final output. Crashing shows the trade-off between cost and time. Helps managers balance fast delivery versus extra cost. Remember, crash only critical activities. Crash with lowest cost per day first. Keep tracking total cost increase. This method is used in real-life project planning in construction, IT projects, event management, etc., where deadlines are strict. Next important long question is, what is PERT? Explain the calculation of critical path using PERT technique. Problem. What is PERT? How to find critical path using PERT with problem. What is PERT? PERT, Program Evaluation and Review Technique, is a project planning tool used when activity times are uncertain. It helps in estimating the total project duration and identifying the critical path, the longest time path that controls the project completion time. PERT time estimates. For each activity, we use 3 time estimates. Symbol meaning example. To optimistic time, best case, 2 days. TM most likely time, normal case, 5 days. TP pessimistic time, worst case, 8 days. Step 1. Calculate expected time, T. Formula. T is equal to 2 plus 4 TM plus TP, 6. Example. 2 is equal to 2, TM is equal to 5, TP is equal to 8. T is equal to 2 plus 4 times 5 plus 8, 6 is equal to 2 plus 20 plus 8, 6 is equal to 30 divided by 6 equals 5 days. Step 2. Build network diagram. Draw activities as arrows and events as circles using the expected times, T. Identify all paths from start-end. Step 3. Calculate total time for each path. Add up the expected times, T, along each path. Example. Path 1, ABD is equal to 4 plus 6 plus 3 equals 13 days. Path 2, ACD is equal to 4 plus 7 plus 3 equals 14 days. Step 4. Identify the critical path. The path with the longest time is the critical path. In this case, ACD is equal to 14 days critical path. Why PERT is useful? Helps in planning projects with uncertain times. Helps managers know the minimum time to complete a project. Used in software development, construction, research projects, etc. Easy tip to remember. OMP method optimistic, most likely pessimistic. Use formula T is equal to 2 plus 4 TM plus TP, 6. Then find the critical path, longest one. PERT is equal to planning when you are not sure of time. Critical path is equal to controls total project duration. Next important long question is 5. Discuss about time estimates used in PERT analysis based on beta distribution. Problem. Time estimates in PERT using beta distribution. What is beta distribution in PERT? In PERT, program evaluation and review technique, activity times are uncertain. So, instead of one fixed time, we use 3 time estimates based on the beta distribution, a type of probability distribution used to model uncertainty in project times. The 3 time estimates in PERT. Symbol time estimate meaning example. To optimistic time minimum time to complete an activity, ideal condition, 3 days. TM most likely time to complete under normal condition 5 days. TP pessimistic time maximum time if everything goes wrong 9 days. These are called the OMP method: optimistic, most likely, pessimistic. Step 1. Calculate expected time TE. To find average project time using these three estimates. Formula: T is equal to 2 plus 4 TM plus TP 6. Example: 2 is equal to 3, TM is equal to 5, TP is equal to 9. T is equal to 3 plus 4 times 5 plus 9. 6 is equal to 3 plus 20 plus 9. 6 is equal to 30 to 6 is equal to 5.33 days. Step 2. Calculate variance and standard deviation. Variance, sigma superscript 2, is equal to TP2 to 36. Standard deviation, sigma, is equal to TP2 6. Example: variance is equal to 9 to 3. Superscript 2 36 is equal to 36 divided by 36 equals 1. Standard deviation is equal to 9 to 3. 6 is equal to 1. Why use beta distribution? Real-life projects have uncertain durations. Beta distribution is flexible and works well with limited data. It helps us understand risk and probability of completing tasks on time. Recap and easy memory tip. OMP plus 4 optimistic plus 4 times most likely plus pessimistic. Divide by 6, you get expected time, T. Use variance and SD to find project uncertainty. Remember, what is equal to when you are unsure about exact time. Beta distribution is equal to helps estimate time with uncertainty. Next important long question is 6. Discuss in detail about resource analysis and allocation. Resource analysis and allocation, operation research, network models. What is resource analysis and allocation? In project management, resources like money, manpower, machines, materials are limited. But different activities in a project may need resources at the same time. So, resource analysis and allocation means using limited resources in the best possible way, so the project is completed on time without wasting or overusing any resource. Why is it important? To avoid delays due to resource shortage. To reduce costs by avoiding idle or overused resources. To balance workload among resources. Key terms. 1. Resource analysis. Studying how much resource is needed for each activity and when. Helps us know peak demand periods and possible shortages. 2. Resource allocation. Assigning available resources to various project tasks. Objective: minimum delay plus efficient usage. 2 main techniques. 1. Resource smoothing. Time is fixed. Used when project deadline can't be changed. Aim is to adjust activities within their float time, flexible period, to use resources more smoothly. No delay in project. Example: if 2 tasks both need 3 workers at the same time, and one has float time, we shift it a bit later to reduce peak demand. 2. Resource leveling. Resources are fixed. Used when resources are limited and can't be increased. We may delay non-critical tasks. Project time may increase slightly. Example: if you have only 5 workers and 3 tasks need to each, we reschedule one task to start later. Simple example. Let's say you are building a house. You have 4 workers, but 3 tasks, plumbing, painting, wiring, all need 2 workers at the same time. You analyze the resource usage and shift one task by 2 days. It has float, so now you are using only 4 workers at a time. Problem solved. Conclusion. Resource analysis and allocation is like budgeting your workers and machines smartly, so the project goes smoothly without delay or waste. It keeps the project balanced, cost-effective, and efficient. Next important long question is 7. A small project is composed of 7 activities whose time estimates are listed below. Activities are being identified by their beginning, I, and ending, J, node numbers. Activities time in weeks. IJ to TMTP. 1 to 117. 13147. 14228. To 5111. 35 to 514. 46 to 58. 563615. I. Find the expected project completed time. 2. Calculate the probability that the project will be completed at least 3 weeks than expected. 3. If the project due date is 18 weeks, what is the probability of not meeting the due date? Here is the complete solution. Problem summary. We are given a small project with 7 activities and 3 time estimates for each activity. 2. Optimistic, TM, most likely, and TP, pessimistic. Step-by-step solution. I. Expected project completion time. We calculated the expected time for each activity using the formula. T is equal to 2 plus 4 TM plus TP, 6. Then we used a network diagram to find all paths from start, node 1, to end, node 6. We found that the critical path is 1356. Its expected completion time is 17 weeks. 2. Probability of completing at least 3 weeks earlier. We want the project to finish in 14 weeks, 17 to 3. We calculated the Z value using Z is equal to X mu sigma, where X is equal to 14, U is equal to 17, and sigma is equal to 9 is equal to 3. Z is equal to 14, 17, 3 is equal to -1. Using standard normal tables, probability is equal to 0.1587 or 15.87%. 3. Probability of not meeting due date, 18 weeks. Z is equal to 18 to 17, 3 is equal to 0.33. From normal table, probability of finishing in 18 weeks or less is equal to 0.6306. So, probability of not finishing is equal to 1, 0.6306 is equal to 0.3694 or 36.94%. Final answers. I. Expected project time is equal to 17 weeks. 2. Chance of finishing 3 weeks early 15.87%. 3. Chance of missing 18-week deadline 36.94%.